All right, so here we are. We're going to talk about motion maps. And the chief tool that we're going to use for talking about motion maps, at least for one-dimensional motion, this is called a ticker timer. And a ticker timer, you can kind of see how there's like this bolt here? And if I touch it with my finger, can you see that the bolt can go like up and down? So that bolt that can go up and down, it's actually going to make contact with, I'll turn it this way. Do you see the disc that's on the screen there? There's this sort of almost purple disc. And if I take that disc off, you can see that there's like a silver, let's call it like, you know, if there's a hammer and an anvil, this is like the anvil, and the hammer is going to come down on that anvil, but this disc is going to be in between the hammer and the anvil. This disc has sort of a purplish one side, but on the other side, it's almost black, and it's carbon. This is a disc of carbon paper, okay? So if you don't know what carbon paper is, it's exactly what it sounds like. It's paper that's covered in carbon, okay? And carbon, is, you may or may not know, is black. So if I were to take this piece of carbon paper and put it down on the page here and just like scratch it or something, then I should be able to transfer, see I can transfer a little bit of carbon to my paper. But that's not what this thing is going to do. What this thing is going to do is I'm going to put this disc between the hammer and the anvil, and when this hammer comes down, it's going to make a dot. Now right now there's no paper underneath of it, but I can take a piece of paper, and the illustration on the paper shows what I'm talking about right now, but I want to make sure you can see it. It's just a roll of paper. See how it looks like a receipt? It's just like a narrow receipt, okay? So we call this ticker tape, and maybe like in the 1920s or something, maybe you've heard of like old-timey World War II type things, ticker tape parades, or maybe you haven't. It doesn't really matter. But it kind of like functioning like something like a streamer, and people using them like streamers. You can also imagine maybe like if this was the era of telegraphs or sending like, you know, messages by wire that precedes telephone. Can you imagine this kind of a strip going through this device? So there's a little bit of a trough there, you can see. Goes in one side, goes out the other side, and if I by hand go and I make the hammer come down, can you see there's a dot that's being formed there? So that dot would get formed as the hammer comes down and like transfers carbon to the paper. Now this ticker timer, I'll let it go and you'll hear it, but it vibrates up and down at 60 hertz. That means 60 times per second. That's 60 hertz. That's how you express frequency, 60 hertz. And people say, well, why does it go up and down at 60 hertz? Why wouldn't it be like some more metric number? Well, you can blame that on, I don't know, the Babylonians or the Assyrians or something with a base 6 number system. But our electrical grid, our AC electrical grid in Ontario, Canada is 60 hertz. The current goes back and forth at a rate of 60 times per second. And so as a result, a device like this is going to make this sound. And you might even recognize the frequency because it's the hum of the electrical transformers that are in our front yards or on the top. You know those gray electrical transformers that might be at the top of poles? They all make this frequency because it's the frequency of our electrical grid. Listen. You ever heard that in the summertime when the transformer really hums? And so our whole electrical, if you haven't, listen to the green boxes, listen to the gray boxes. It'll make a frequency that sounds like that, okay? Now if I take this paper out, you see that I made one dot. The reason I made one dot is because my paper didn't move. But if I feed this thing through, here, I'll turn it on. You see that I got a bunch of dots there? And the amount of time between each one of those dots was 1/60th of a second. Follow? Now, I want to take my ticker timer off to the side. We're going to use this for a lab. We're going to attach one tape to something that's going to roll along at whatever speed. And I want to just talk about these dots for a second. I'll zoom in a little bit closer. I'll set my focus. And I want to talk about these dots. Now, if I go to one end of this data, you can see that one end of this data, there's some kind of messy data. This is before I started moving. So I just want to slash that out and say, I don't care about that. I see that this one right here, that's my first distinct dot. We all agree that's my first distinct dot? And if that's my first distinct dot, I'll set it so I can read from left to right. I'm going to say that's dot 0. And I want to propose this. I want to say that if the frequency that these dots got laid down at was 1/60th of a second, because that's what 60 hertz means, 1/60th of a second, the space between this origin and this first dot was 1/60th of a second. So I'm going to do something that might seem arbitrary at first, but it'll make sense, okay? If I go 1, 2, 3, 4, 5, 6, and I circle this one, notice there are 6 gaps there now. right? Each one of those gaps was 1/60th of a second. Now, if I think this out a little bit further, 6 gaps times 1/60th of a second, what fraction or what decimal of a second is that? 6 divided by 60. Yep. It's 1 over 10, or 0.1, right? And if I even do one further, if I say it's actually 1 divided by 60.0, if I claim that our electrical grid is accurate to 3 significant figures, then 1 divided by 60 would be equal to, he says 1/10, I could say 0.100 seconds. 1/10 of a second to 3 significant figures, right? And so what that means is that at this point here, that's 0.100 seconds. And if I count further along by this rationale, I should be able to say 1, 2, 3, 4, 5, 6. This dot happened at 0.200 seconds. All cool? Now what we've been talking about up to this point is using positions and times to talk about velocities. And so that's kind of where we're going next with this, is I could take this data and I could use a ruler and I could say, okay, well that dot happened at a time of 0.1 seconds and it had a position of, and I could measure out how many meters. And I could say this one happened at 0.2 seconds and it had a position relative to the origin of so many meters. And I would measure it in centimeters perhaps and then move the decimal place over a couple of times, but then I would get position information and I would have time information, right? And so basically what this is a nice like physical copy of the position in time for an object that's in motion. And so we're going to use ticker timers for motion maps. We're going to use these motion maps to graph data, and then we'll use that to make some analysis for an upcoming lab. Okay, so that was just like a little bit of groundwork to explain why we're doing what we're doing right now.